This is section 1.2, and we're going to talk about combining like terms. So, of course, our learning goal is to understand how to combine like terms. And if you want, think about how to phrase that as an essential question so that your left-hand column questions and your summary focuses on answering that question. How do I combine like terms? Okay, so I want to review a couple of things that we've actually already talked about this year. Remember that expressions are made up of constants, operations, variables, of course, and terms. So when we think about an expression, only these things are used to create an expression. Remember, the difference between an expression and an equation is that an equation has an equal sign and an expression doesn't. So if expressions are made up of terms, as part of all of the things, how do we tell the difference between variables, constants, operations, and terms? Well, this is super important. Terms are separated only by addition or subtraction. They're not separated by multiplication or division. And that's how I can tell the difference between where one term starts and where one term ends. Okay, so let's do just a really quick example. How many terms are in this expression? Well, here, where we have 4x squared, that really means 4 times x squared, but we know that terms are only separated by addition and subtraction, so 4x squared is one term. 3x is one term because it's separated by addition from the 4x squared. 2 is one term because it's separated by 3x with the subtraction. And then 9y is a term because it's separated from the 2 with addition. So in this particular case, there are 4 terms. 4x squared is a term, 3x is a term, negative 2 is a term, and 9y is a term. Okay, so let's talk also about coefficients. When we have a term that multiplies a number by a variable, that number that's doing the multiplying is called a coefficient. It's the factor of the variable. So let's just do a few examples here. If I have 3 times x, the coefficient is the number that's getting multiplied by x, so that would be 3. Even if I have x raised to a power, like if I have 5x squared, 5 would be my coefficient. If I have negative 2y, that's like saying negative 2 times y, so negative 2 is my coefficient. Remember this when we had just w? We could think about that as 1 times w, so 1 is my coefficient. And again, if I had negative x squared, that's like saying negative 1 times x to the fourth, so negative 1 is my coefficient. Let's talk a little bit again about constants. Remember, constants are just numbers that we're adding or subtracting to our expression. So it's just a number. So if we had these expressions here, if we have just the expression 2, yeah, it's an expression, and the constant is 2. If we have the expression 3x plus 4, the constant's the number that we're adding on at the end, so the constant is 4. If we're subtracting a constant, I usually like to think of that constant as negative. That constant is negative 9. And the reason that's true is because we could rewrite that expression as 5x plus negative 9. So negative 9 is my constant. And in the last example, we have 2y squared plus y plus 1. Not a constant, not a constant. The only thing that's a constant in this expression is the number 1. Okay, so we've reviewed coefficients, we've reviewed constants. Now let's talk about terms. So let's list the number of terms, in other words, how many terms there are in each one of these examples, what the coefficients are, and then the constants in each of the expressions. So the first one, we have 3x plus 4. Remember, plus and minus separate how many terms I have. So in this case, there will be 1, 2 terms. Coefficients are what's getting multiplied by your variable. So in this case, there's only one variable, 3x, or x is my only variable, so 3 is my coefficient. And my constant in this case would be 4. In the next one, we have 4x plus 3y minus 6. So first let's look at our pluses and minuses. We have a plus here and a minus here. So that means that there are 1, 2, 3 terms. If I look at my variables, we have 4x and we have 3y. So we actually have two different coefficients. 4 is the coefficient of x, 3 is the coefficient of y. And then my constant at the end would be negative 6. In the next example, we have x squared minus 25. So we have one subtraction symbol here. So there are 2 terms. And if I want to do the coefficient, look at the variable. What's being multiplied by x squared? That's like a 1 times x squared. So my coefficient is 1, and my constant is negative 25. In the last one here, we have subtraction, addition, addition. So there are 1, 2, 3, 4 terms in this case. And again, we have two variables. They're both x, but they show up twice. So 2x is a variable term, 3x is a variable term, so we have two different coefficients. 2 is a coefficient, 3 is a coefficient. And we have two different constants. We see negative 1 and positive 3. So negative 1 is a constant, and 3 is a constant. Now that we're comfortable with that, we can talk about like terms. So we say that like terms are terms that have these two things. They have to have the same variable, and that variable needs to be raised to the same exponent. So here are some examples. 3x and 4x. Well, we don't even see an exponent here, but it's really there. The exponent here is really 1. So this is 3x to the first and 4x to the first. So those are like terms. 2y and negative y are like terms. Again, that's like 2y to the first and negative y to the first. And then if we had x squared and negative 10x squared, same variable, both being squared, so it's raised to the same power, so those are like terms. By the way, constants are also like terms. They don't have a variable, but they really can be written as a variable by saying it's x to the 0 power. You may remember that anything to the 0 power is 1, so this is really like saying 4 times 1. If you're not familiar with that, that's okay. Just understand that constants are also going to be like terms for us. Okay, so let's identify the like terms in this expression. We have negative x squared, 5x, negative 4, negative 3x, and positive 2. Those are all of the different terms in the expression. So if I wrote out the terms separately, we have negative x squared, we have 5x, we have negative 4, which is a constant, then we have negative 3x. Well, we already had a term that was an x term, so 5x and negative 3x are like terms. And we also had another term that was a constant. Negative 4 was a constant, and 2 is a constant. So those are like terms. So if we could say negative x squared doesn't have any like terms, but 5x and negative 3x are like terms, and negative 4 and positive 2 are like terms. Okay, so that's how you can identify what the like terms are. Once we've identified them, our goal here is to combine them, right? So once we know how to combine them, we say that we are simplifying expressions. So really, it's the distributive property that allows us to combine like terms. And once we've done that, we say that an expression is simplified if it has no grouping symbols and if all of the like terms have been combined. The way that we combine like terms is by adding their coefficients. And really, like I said before, it's the distributive property that allows us to do this. We don't always see the distributive property when we combine like terms, but it's really there, and I'll show you why. For example, if we had the expression 3x plus 4x, the distributive property says, well, that's really like saying x times 3 plus 4, right? If I started with this expression here and applied the distributive property to it, we would say this is equal to x times 3, right, plus, because this is plus, x times 4, and the way that I would write that out would be 3x plus 4x. So instead of applying the distributive property to this expression, what we're going to do now is work backwards and use order of operations to add what's in the parentheses. 3 plus 4 is 7, so this is equal to x times 7, and the way we would write that is 7x. So that means that 3x plus 4x is equal to 7x. Now, of course, the easier way to think about this is just if we have like terms, add their coefficients. 3 is a coefficient, 4 is a coefficient, 3 plus 4 is 7, so 3x plus 4x is 7x. So let's look at a few examples of combining like terms. In example 4, we want to combine like terms and simplify the expression. So we have to first identify our like terms. In this first problem, 8x and negative x are like terms. And remember, you might want to think about that as 8x and minus 1x. Okay, so those are our two x terms, so they're like terms. So think, what's 8 minus 1 is 7, so we have 7x. And we don't have any other constants to add to the 4, so my final answer would be 7x plus 4. In the next example, we have 2y plus 9 minus 4y. So my like terms here would be 2y and negative 4y. And it doesn't matter that they're not next to each other. We still want to add 2y minus 4y, and minus 4y because the minus is with the negative 4, so that stays with there. And then we'll add the 9. So now let's combine 2y minus 4y. That's like saying 2 plus negative 4, which is negative 2y. And then we have our constant term plus 9. Alright, in the next expression, we've got a bunch of stuff going on here. We've got 2x squared plus 7x squared minus x squared plus 2. So 2x squared, 7x squared, and minus x squared are all like terms. And remember, you could think about that as negative 1x squared. So add their coefficients. We're going to add 2 plus 7 minus 1. And that's going to be the new coefficient of our x squared term. So 2 plus 7 is 9. 9 minus 1 is 8. So combining like terms gives us 8x squared plus 2. So this is the simplified form of that expression. Alright, now let's see what happens when we have some grouping symbols. So for example, we have 8 minus 2 times x minus 4. So what we have to do here is apply the distributive property first. And then once we do that, then we want to combine our like terms. Okay? So, when we apply the distributive property, pay attention to your pluses and minuses. Remember, we're going to think about this as -2. So the 8 stays 8. But then we have -2 times x. So -2 times positive x is -2x. But then we have -2 times -4, and a negative times a negative is a positive. -2 times -4 is positive 8. Now we can combine like terms. We have two constants here, 8 and 8. So we can write this as 8 plus 8 is 16. So we can write this as 16 minus 2x. Now, here's something to think about. Usually when we write expressions, we want the variable term to come first. So this is actually equivalent to -2x, because the x term is negative, plus 16, because 16 was positive. So if I rewrote the order of those two terms, it would be -2x plus 16. Alright, let's do the next one. So applying the distributive property first, we have 2 times x, which is 2x. Now we have plus, so this is a plus, 2 times 3, which is 6. Then we're going to add to that, because this is a plus, 3 times 5, which is 15, and then 3 times negative x. Positive times a negative is negative, so -3, or positive 3 times negative x is -3x. Now let's combine like terms. We have 2x and -3x. So those are like terms. Then we have +6 and +15. Alright, so 2x minus 3x, that's 2 minus 3, or 2 plus -3, so that's -1x. And then we have +6 and +15, that's +21. So here my final answer is -1x plus 21. But of course, I would prefer for you to write just -x plus 21. We don't need the 1 as the coefficient when we write our x term. So -x plus 21. Okay, so go back, put your example questions on the left like we talked about. I want 3 to 4 sentences for your summary. I want you to do that immediately, right now. After you've done your notes, questions and summary first, then you can do your practice problems. Make sure your summary includes something about how to tell if you have like terms. And you might also want to talk about the other vocabulary we discussed today, which were coefficients and constants and terms themselves, how to tell where you separated terms, okay? So do your complete summary, answer the essential question, how do I combine like terms, and get your questions on the left.